Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day everyone. Okay, so today is our first synchronous lecture for chapter 3, and this synchronous lecture is for week number 6. Okay, for week number 6. Alright, so if you remember, during our last synchronous class in week 5, we have started discussing about introduction to this derivative, chapter 3, part A, kan? So from my previous lecture, by now you should know what does it mean by secant line and how does it differ from the tangent line. So ada dua types of line that you should know, and the rate of change or the slope of the secant line, okay, the slope of the secant line ataupun dia sama juga dengan what we call as the average rate of change is given by this formula. Okay, by this formula, because secant line is connecting 2 points on the curve, a straight line that connect 2 points on the curve, where tangent line is a straight line that only touches at one point of the curve yang hitam ni. Okay, so to find the slope of a tangent line is given by this formula. Okay, limit fa tambah h minus fa over h, or you may use the second one is also the same, because x minus a is actually equals to h, or x is actually equals to h plus a. H plus a ni maknanya is another point. Nampak ini? Remember the one that I have explained to you before in our previous lecture. Those who missed my lecture last Thursday, please go to eLearn and have a look at the recorded video. Okay, I put it as first part. Okay, chapter 3, first part. Okay. So now, if I'm not mistaken, during our last lecture, we halfway done with example 1, question 1. Okay, we have done so far example 1A and 1B. Okay, so now what I'm going to do is we are going to proceed with example C and D. Okay, we have example C and D. Alright, so for example C, let's try. Find the instantaneous rate of change. So if it is instantaneous rate of change, with the word instantaneous, okay, instantaneous here, it indicates that we are actually looking for the slope of the tangent line. Okay, the slope of the tangent line, or in other words, it is known as instantaneous rate of change of y respect to x at the general point x equals to x naught. We have discussed in our last class, actually almost the same B and C, but for B it is state the value of x we want to determine is instantaneous rate of change is at x equals to -4. But here we want to determine its instantaneous rate of change at general value of x. Maknanya x into can be any value, can be x equals to -4, but it can be also x equals to 4, x equals to 0, or whatever value that you wish to check. Okay, so because of that, we denote that any value of x become x naught. Alright. So I'm going to write here. So we have empty spacious space to write. Okay, we have y equals to, the function is actually y equals to x squared plus 1, right? And we want to find instantaneous rate of change, okay, at x equals to x naught. Okay, x equals to x naught. Okay, so in this case, we are going to use the formula that we have discussed before. We have two formulas that you may use. Sama ada you nak guna dalam bentuk H, or you just use dalam bentuk X. Okay, because here it is mentioned X is equals to X naught. So we use X approaching X naught. I'm going to use the second formula. Okay, so we have fx minus with f x naught and then minus over x minus with x naught. Okay, the formula is this one. Okay, saya guna yang ni. Maknanya sekarang our A here, nilai A is x naught. A is equals to x naught. Okay, kalau you nak guna yang ni pun boleh. Okay, maknanya ganti je lah x naught tu A become x naught. Maknanya f x naught plus h minus with x naught over h. But for me, I think this one become a little bit complicated lah. Alright. So this one, we're gonna do fx is, okay, sekarang ni kita ada y equals to fx is equals to x square plus 1. So kalau kita fx naught ni, maknanya y equals to fx naught. So how can we get fx naught? Very simple, you just ganti x ni with x naught. So we have x naught square plus 1. As simple as that. Alright, so here we have limit x approaching x naught. Fx is x square plus 1 minus with x naught. Our x naught is x naught square plus 1 over x minus with x naught. So in this case, what we're going to get is x approaching x naught. So we have x square plus 1 minus x naught square minus 1. Ni nampak ni, darab masuk. So it become negative over here. So you see, this one, 1 and minus 1 you may cancel. So what we're going to have here is we have limit x approaching x naught, x square minus x naught square over x minus x naught. Again here, in chapter 2, I have mentioned about this. Okay, remember, whenever we have x minus a times with x plus a is actually equals to x square minus with a square. Okay, so meaning to say this one, x square minus with x naught square is equivalent to x minus with x naught times with x plus with x naught over x minus x naught. By the way, kenapa kita factor macam ni? Okay, this is again just like a revision to all of you because we have discussed into details about this in the previous chapter kan. Kalau you ganti x with x naught aside x here, cuba kita tengok apa yang you akan dapat. Okay, this is like for this, maybe for the direct intake, this is your first time. If you haven't seen my previous chapter's lecture, so I'm going to explain this again lah. X approaching x naught, maksudnya kita gantikan x ni dengan x naught kat dalam ni. So you see when you gantikan x with x naught, we're going to have x naught square minus with x naught square. And down also we have x naught minus with x naught. Kita dapat x naught square minus with x naught square over x naught minus x naught. So we're going to get 0 over 0. So 0 over 0, we are not allowed to have such a thing. 0 over 0, if it is limit, we get 0 over 0. It seems that it gave you hint that the limits is somehow exist, but you have to do something in order to get the limit value. But for f at 0, dia does not exist. Okay, so for those who haven't tak khatam lagi chapter 2, make sure whenever you have khatam chapter 2, you understand what does it mean by the difference between fx naught dengan limit fx as approaching x naught. Okay, yang ni menghampiri tapi tak sama yang ni when x is equals to x naught. So for this case, fx naught does not exist. That's why kita dapat kosong over kosong. However, for the limit, if you direct ganti, you dapat kosong over kosong. It give us hint that actually the limit does exist. Limit does exist provided you have to do something. Okay, what is that something? It's like this lah. because we want to get rid of the denominator that make the function become 0. So from x square minus with x naught square, we replace with x minus x naught times with x plus x naught over x minus x naught. With this, you may cancel x minus with x naught. Kan? Dan dah tak ada dah lah isu kosong over kosong ni. So when you ganti with x naught, we're gonna have ganti this x with x naught. So your final answer is 2 times with x naught. 2 times with x naught. Okay, so we're done with question C, 1C. Okay, now we're gonna proceed with D, the last question for example 1. Find the slope of the graph at the point 2, 5 and use it to find the equation of the tangent line y equals to x square plus 1 at x equals to 2. At x equals to 2. So soalan ni sama juga sebenarnya. We have y equals to x square plus 1. Dia nak you cari equation dia nak suruh you cari slope of the tangent line at x equals to 2. Okay, so remember, what is slope of the tangent line? Slope of the tangent line is actually the same as the instantaneous rate of change at x equals to 2. Okay, slope of the tangent line ni sama lah dengan instantaneous rate of the change at x equals to 2. Maknanya kalau graph tu kan y equals to x square plus 1, macam mana graph y equals to x square plus 1? Macam ni kan, when x equals to 0, y equals to 1. Dia quadratic graph, so this is how does the graph looks like. And it is at tangent line y equals to 2, x equals to 2, y here perhaps equals to 5. So the slope of the tangent line ni maksudnya it only touches the curve 1. So we're going to have a straight line. Maybe saya lukis ni tak cantik lah, tak tepat, bukan tak cantik, tak tepat. Okay, but imagine lah, ataupun you boleh draw sendiri lah kalau you rasa macam tak betul ni, nampak macam it touches at many points. Okay, imagine je lah macam tu lebih kurang. So it touches at only one point at x equals to 2. So we want to find the slope of this tangent line. Okay, the slope of this tangent line. So the slope of this tangent line is actually equivalent to the instantaneous rate of change. Okay, slope saya buat ganti dengan m, slope. Limit x approaching apa sekarang? X approaching 2 lah. Okay, x approaching 2 because we want to find the slope of tangent line at x equals to 2 or instantaneous rate of change at x equals to 2. Benda yang sama. Okay, limit x approaching 2. Okay, fx minus with f2 over x minus 2. Okay, so again fx is equals to x square plus 1. Kalau f2 pula is going to be equals to 2 square plus 1, which is equals to 5 kan. Okay, so kat sini what we're going to have is fx, okay, limit x approaching 2, our fx is equals to x square plus 1 x square plus 1 minus with 5 over x minus 2. So we have limit x approaching to x square minus 4 over x minus 2. So from here we have at limit x approaching 2. Nampak pattern dia sama je macam tadi, but now we have x square minus 4. 4 ni sebenarnya adalah apa? 2 kuasa 2 kan. So we have x minus 2 times with x plus 2 over x minus 2. So with this we make cancel and then we ganti 2 ni ke dalam x plus 2. So we have 2 plus 2. Then the answer is equals to 4. Alright. So this is M. We're done. But in this question they ask you one more thing, which is to find the equation of the tangent line. Okay, equation of the tangent line here. Equation of the tangent line is equals to what? Okay, equation of the tangent line is just equation of a straight line, right? So y minus with y1 equals to mx minus with x1. So for this case, we know m is equals to 4. And you need to know one point, x1 and y1. Now we have already the x point, which is equals to 2. And what is when x equals to 2, y equals to 5, kan? Y equals to 5. Y when x equals to 2 is equals to 5. So we have the answer already. Y minus with 5, m is equals to 4, x minus 2. So this is your final answer or the equation of the tangent line. Okay, for question D. Alright. Okay, so now we discuss the question number 2. Basically, kalau tengok soalan ni lebih kurang sama je. But this is an application types of questions. Okay. So for number 2, suppose the amount of air in a balloon after T hours is given by ni. Okay. Amount of air in a balloon. Udara dalam balloon. Dia punya amount of kandungan udara dalam balon tu dia diwakili oleh persamaan VT is equals to T cube minus 60 square plus 35. Okay, dan kita tahu balon tu makin lama dia akan mengecut, kan, maknanya udara tu akan keluar. So we want to know, okay, slowly udara tu akan keluar, dia akan mengecut. So the question asks, find the instantaneous rate of change of the volume, maknanya kandungan udara dalam balon tu selepas 5 hours. Okay, after 5 hours, after 5 jam. So untuk mengetahui itu, maknanya kita kena tahulah berapa banyak udara tu keluar, berapa banyak udara tu keluar per hour. Okay, so it is given by equation, the amount of air in a balloon after T hours sebanyak ni. So berapa banyak dia keluar per hour, maknanya instantaneous rate of change, perubahan udara berkadaran dengan masa. So it is given by, okay, equation dia untuk kandungan udara, amount of air in a balloon after T hours diberi oleh VT equals to T cube minus with 60 square plus 35. Betul ke? Okay. Okay, it's given by VT minus T cube minus 60 square plus 35. And we want to find the instantaneous rate of change at T equals to 5. Maknanya after 5 hours. Okay, kalau sebelum ni kita duk guna X, so X ke T ke Q ke whatever, that is only variable, pemboleh ubah. So it's not a problem. Kenapa sometimes X, kenapa T? You can use any kind of variable as you wish. Okay, so for this one we have this equation and we want to find rate of change, perubahan, okay, now with respect to masa T. Okay, so in this case, in order to find instantaneous rate of change at T equals to 5, okay, you may find, okay, you may use limit Vt minus with V5 over T minus 5 as T approaching 5. Okay, so Vt kita ada T cube minus 60 square plus 35. So you need to find as well V5. So how to find V5? Senang je, masukkan T ke dalam, T equals to 5 ke dalam equation. So we have 5 cube minus with 6, 5 square plus with 35. So here we have 5 kuasa 3, malah nak kira tekanlah kalkulator, tapi saya nak guna sendiri. 5 darab kuasa 2, 25, darab dengan 5, 125. 6 darab dengan 5 kuasa 2, 6 darab dengan 25, 150 tambah dengan 35. So in here we get 125 tolak 150 is negative 25 tambah 35, we get 10. Okay, so here we have limit t approaching 5, vt kita adalah t cube minus 6t square plus 35 minus with v5 kita is only one number, 10 minus 10 over t minus 5. So in this case, this is going to be equals to limit t approaching 5, t cube minus with 6t square, 35 minus 10 is plus 25 over t minus 5. Okay, yang ni macam lain macam sikit kan. It looks like something different because this time is t cube. Sudah. T cube minus 6t square plus 25 over t minus 5. Okay, ni per ni maksudnya apa? Okay, per ni maksudnya dia bahagi, betul? I don't think it's possible for you to factor it easily right now. Okay, so I'm going to show you there's one conventional method. Kalau you tengok macam ni, 10 per 5. Dapat berapa? 10 per 5 dapat 2. Macam mana kita dapat 2 ni? Just back to like old school style. 10 bahagi dengan 5. Betul tak? 5 darab dengan berapa dapat 10? 5 darab dengan 2 dapat 10. So 10 over 2 darab 5 turun ke sini, betul tak? 10 tolak dengan 10 dapatlah kosong. So that's why kita tahu 10 bagi 5 sama dengan 2. Ni macam you belajar masa sekolah rendah dulu kan? Dalam bentuk lazim, tak lazim semua tu. So now to solve this, okay, we unable to solve it using bukan unable, boleh tapi it's a bit complicated. So we're gonna use this old school method. Macam mana? Samalah, maknanya yang ni t cube minus 6t square plus 25 ni akan berada di dalam minus 6t square plus 25. Okay, kita akan divide dengan apa? T minus 5. Okay, kita akan divide dengan t minus 5. Okay, so t cube. T darab dengan apa nak dapat t cube? T kuasa 3. T darab dengan apa nak dapat t kuasa 3? Of course, t darab dengan t kuasa 2 kan? So, t kuasa 2 darab balik dengan t ni kita akan dapat t kuasa 3. And then t kuasa 2 ni juga kita darabkan dengan 5. So, we're gonna have negative 5t square. Okay? Dan daripada sini, macam mana? Macam tadi lah, 10 tu kan kita tolak dengan 10. So, tolak jugalah. T cube minus with t cube. So, dapat kosong kat sini. Minus 6t square tolak dengan tolak 5. So, dia akan jadi tambah kan. Minus 6t square. Dia akan terdapat minus 6t square tambah 5t square. So, kita akan dapat negative t square. And then tambah 25 tolak kosong kat sini. Tak ada apa-apa. So, tambah 25. Okay. So, next. Negative t square darab dengan apa? T darab dengan apa untuk dapat negative t square? Okay, darab dengan negative t lah. Negative t. So, negative t darab dengan t, kita akan dapat negative t square. Negative t darab dengan negative 5t, kita akan dapat positive 5t kan? Positive 5t. Okay, so daripada sini kita tolak. So, negative t square tolak t square, kita akan dapat kosong lah. Okay, kita akan dapat kosong. And then kat sini tak ada t, kita ada 0t. So, 0t tolak 5t, kita akan dapat negative 5t. And then 25 tolak dengan, kat sini pula kosong. 25 tolak kosong, kita akan dapat tambah 25. Okay, so the last one dah ni. T darab dengan apa nak dapat negative 5t? Of course lah, darab dengan negative 5, betul tak? Darab dengan negative 5. So, t darab dengan negative 5, kita akan dapat negative 5t. And then negatif 5 darab dengan negatif 5 ni kita akan dapat positif 25. So nampak tak? Sekarang ni kita tolak negatif 5t tolak 5t. Maknanya negatif 5t tambah 5t kita dapat kosong. 25 tolak 25 kita akan dapat kosong. So settle. So maknanya kat sini. Okay, maknanya kat sini. T cube minus 6t square plus 25 divide dengan t minus 5 is gonna be equals to limit t approaching 5 ni, hasil bahagi dua nombor ni, dua function ni, kita akan dapat t square minus 6t minus 5. Dah tak ada lah ni, t over 5 ni dah tak ada, sebab ibarat macam 10 bagi 2 sama dengan 5 tadi tu. Okay, then daripada sini kita boleh terus masukkan value t tu sama dengan 5. So we have 5 square tolak 5 tolak dengan yang ni tadi. Okay, betul lah. 5 square tolak 5 tolak 5. So what you have? 25 minus with 10. So you get the answer is equals to 15. Okay, so that is the amount of udara di dalam balloon after 5 hours. Okay. Okay, sorry. Not the amount of after 5 hours. The instantaneous rate of change, maknanya perubahan udara di dalam balloon tu after 5 hours adalah sebanyak 15 kandungan udara apa? Isi padu dia lah, meter cube ke apa per hour. Okay, 15. Okay, so sekarang ni jawapan dia adalah 15. Okay, 15. Later on, ataupun siapa yang dah belajar differentiation seperti ni, you can actually get this answer without having all the hassle here. Okay, how can we do that? You just need to differentiate, kan? How to differentiate. For those siapa yang dah tahu how to differentiate, you go ahead and try to differentiate. Find v prime t and replace with t equals to 5. You should get also equals to 15. Okay, so what we have done here is on the the fundamental of the derivative. Adakah every time kita nak cari instantaneous rate of change, we have to go through all such method like this? Actually not. Okay, this is only for you to understand the basic of the differentiation sahaja. Okay, so now we are moving in order to straight away and in order to understand further about differentiation, and after this we terus apply rules of differentiation. Tapi it's very important and crucial for you to understand apa maksud differentiation tu. Okay, alright, so that's all for the first part of the video for today's asynchronous lecture, which is considered as part 2 of chapter 3 lah. Alright.